Okay, so stoichiometry, or stoichiometry, I don't know. Just S-T-O-I-Ch-metry. So basically stoichiometry is just a giant word for dimensional analysis, and it's pretty simple when you get down to the basics. So what you're trying to do in stoichiometry is figure out the amount of a certain substance that is needed in a chemical reaction to produce another substance. So the first step of stoichiometry is going to be balancing an equation. And after that, it's really just math. So the first step of stoichiometry, as I said, is balancing an equation. So an example problem would be how much manganese dioxide will be needed to prepare 250 grams of chlorine from hydrochloric acid. So the first thing we know is that manganese dioxide, which would be MnO2 because it's dioxide, is a reactant because we know that how much of it is going to be needed to make 250 grams of chlorine. So we know that manganese dioxide will form with something, forms Cl2 plus something. And it says that it reacts with hydrochloric acid, so HCl. So if chlorine is one of the reactants, then manganese chloride will have to be one of the reactants, and water will be one of the reactants. So plus MnCl2 and H2O. So our first step would be to balance the equation. So what we do is we got all this crap, and all we really need to do is just put a 4 here and a 2 here and we're good. Because then we have 4 hydrogens, 4 chlorines, 1, 2, 1, 2, 1 magnesium, 2 oxygen. Alright, so after you balance your equation, what you need to do is figure out how much of what you're trying to find. So what you're trying to find is how much manganese dioxide do you need to make 250 grams of chlorine. So what we do is we take the molar mass of these objects. And so we know we're getting 250 grams of chlorine. So we go 250 GCl2. Make our lines. Oh. Basically, you just use dimensional analysis to solve the problem. So 250 grams Cl2. Here, I'll switch markers so you can see better. Okay, so 250 GCl2. Make our lines. This is more than likely just a giant dimensional analysis problem. Alright. So what we do from here is now 1 mole of Cl2 is 35.45 times 2, so 70.9 grams. And since we're going dimensional analysis wise, we have to put the grams on the bottom and the moles on the top so that the grams cancel out. Draw a line. Now we go 1 mole Cl2 is 1 mole MnO2. And this is actually true because what happened is we took from the balanced equation, which was MnO2 plus blah blah blah, the coefficients of MnO2 and Cl2 were 1. So the molar ratio is 1 to 1. So there's 1 mole of chlorine for 1 mole of magnesium dioxide. Now, this is just going to continue over here. And so now that we know the molar ratio, we can go and find the molar mass of MnO2. So 1 mole MnO2 is equal to, what is the molar mass of that? That's awkward. Okay, so the molar mass of MnO2 is 86.93 grams. And that was embarrassing, so I put on a silly hat. Now what we do is we just multiply the top. So we multiply 250 by 86.93, because remember this part should just be over here, but my writing's too big. And then we divide by the bottom, which should be 70.9 times 1 times 1, so divide by 70.9. So 250 times 86.93 divided by 79 is 306.386 grams. Blah. And the correct way to write the answer would be grams of MnO2. That's a little small. But, so now I'm going to do a different problem, except this time the molar ratio is going to be different than 1 to 1. So that means that we're going to be looking at different multiplication and division numbers. So, alright. So, how many grams of sulfuric acid will react completely with 45 grams of aluminum? So, H2SO4, because sulfuric acid would be H2SO4, plus Al forms... So, how many grams of sulfuric acid will react completely with 45 grams of aluminum? Will form... So, this is just a single replacement problem, so H2 plus Al2SO4, 3. And we know that because SO4 is 2 minus, Al is 3 plus, So 2Al and 3H2SO4. So we know that we have 45 grams of aluminum, so 45 GAl. And we also know that 1 mole of Al, that's on the top. 1 mole Al is equal to 26.98 grams. 0.98 G. And now, our molar ratio is different for this because we have 2 moles of aluminum reacting with 3 moles of hydrogen 2 sulfide. Sulfuric acid. So, we go like that, and we have 2 moles Al and 3 moles H2SO4. And now over here, we're going to still keep it as 1 mole H2SO4, which the molar mass of H2SO4 is 98.08 grams. 98.08 G. Alright, now that we have that, just multiply, 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 divide, 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 and you get 250, and well, since we actually get 256-ish point something, but since the significant figures, we had 45, so we have to follow our sig figs and write our answer as 250 grams of Al, or 250 grams of H2SO4. Yay! Alright, if you have any questions, as usual, Twitter at #ChemistryGod, or just send me a Facebook message. And that's it. Thanks for watching.